So the first problem for today is consider a second order transfer function. This one, we are given a second order transfer function. For the unit step response to have a percentage overshoot of 10%, what should be the resonant peak MR in the Bode plot of the system? Okay. So first of all, one of you tell me if we have a unit step response of a second order system, what is the formula for a percentage overshoot?
e power minus 5 zeta by root over 1 minus zeta square into 100.
Yeah. Okay, let's just keep this. So this is, we want this to be 0.1. So for this, calculate what zeta should be. Yes, someone? What should the value of zeta should be for this to be 0.1?
The voice is not audible actually.
Hello, is my voice audible now?
Yes,
Sir,
sir, audible.
it is audible, sir.
Yeah, okay. Mr. Leela Kumar, maybe you can check your speaker if there is an issue with that. Yeah, okay.
Okay.
Yeah, it is audible now, right?
It is audible now.
Yeah, okay. Yeah, so someone give me this answer. This is the percentage overshoot formula. We want it to be 10%. So what should the damping ratio be?
Sir, is it 0.59?
0.59. Okay. So now what is the resonant peak? We want to find out the resonant peak in the Bode plot of the system. So if you find out for a second order system, when we take the magnitude, then we can if you substitute s is equal to j omega in this g function, then you'll get some complex term, and when you take its magnitude, you'll get another very complex term. I'm not doing the calculation, but so that will give us the frequency response of the system, second order system. So given the magnitude of the frequency response, this is some function of omega, right? So when we differentiate this by d omega is equal to 0, then that will give us the maximum for the the peak of the Bode plot of the system. So for that, the formula is given by MR is equal to 1 by 2 zeta root 1 minus zeta square. So can someone now calculate this one?
1.049.
Yes, correct. 1.049. So this is the resonant peak in the Bode plot of the system. Any issues with this question? Anyone has any doubt?
No, sir.
Oh, okay, so we move on to the next question. Now we are given a transfer function g of s, which is of this sum form. Two zeros are there, there are 4 poles, and we are told that the Bode plot of the system is also given, right? So what do we want to find out? We want to find out the value of k. So tell me now, how can we find it? This is the Bode plot of the system.
So from 1 to 2, the slope is minus 20 dB per decade. So it indicates that there is one pole at origin.
Yes, which we can see from here, right? There is one pole at origin, correct. Then, how do
From
we
2
determine
to
K?
4, 2 to 4, since the dB is 0, it indicates that there is 1 0 present.
Yes, there is one 0 present at 2, correct.
Similarly, from 4 to 8, since the slope is 20 dB, again there is 1 0 at 4.
Yes, that is correct. Here we have one 0, here we have one pole, another pole, and final pole. But how do we determine the constant value K?
So, but for that we have to know at what value is the border plot starting, isn't, sir?
Yeah, but here you can see you are given one information, that is if from starting from 1 I go up till here till 8, then my magnitude will reach 0. Okay, so this is 0 dB, and we know that at omega equal to 1, since all of the zeros and poles, we have the function as k 1 plus s by 2 1 plus s by 1 by a by s into 1 plus s by 8 into 1 plus s by 16, sorry, 1 by b into 1 plus s by 36. Okay, this you can obtain from, like, this is basically the given transfer function g of s. Now, since all of this and everything is in what do we say, the normal form, that is at omega equal to, let us first write g j omega, that is k 1 plus j omega by 2 1 plus j omega by 1 by a, and so on, right? So when we put in omega equal to 0 and find the magnitude, the only term remaining at omega equal to 0 will be 20 log k, correct? So at this value, the value is 20 log k, right? And here I am reaching 0 if I continued at a slope of 20 dB. So from that, can you solve what is the value of k? Yes, so we have 20 log k as the value there. Then we are having a line at minus 20 dB per decade, right? Minus 20 dB per decade. But now, what does this mean? This is essentially minus 6 dB per octave, correct? So, and here from 1 to 2, then from 2 to 4, then from 4 to 8, we have 3 octaves. So, in 3 octaves, at a slope of minus 6 dB per octave, I can go minus 18 dB, correct? So that means from the value here 20 log k, in 3 octaves I am going to 0. From 20 log k, in 3 octaves I am going to 0. That means, and we are saying in 3 octaves the fall would have been minus 18 dB. So that means 20 log k is equal to 18 dB. So this implies k is equal to,
Not clear. Actually, sir, can you repeat? I am not getting this. How that slope 20 you have put, sir?
okay, can you see the figure?
Yeah.
Yeah,
This 20 log K, I understood.
20 log k you understood. This 20 dB is given to us, it is given in the question. For this transfer function, the Bode plot will be like this. And as you
Okay.
can see, there is a pole at origin. So from starting, we'll have a minus 20 dB per decade slope. And minus 20 dB per decade, implies minus 6 dB per decade, correct? Sorry. Minus 20 dB per decade implies minus 6 dB per octave,
Okay.
correct? So,
Yeah.
these two are equal, and see that from 1 to 8 we have 3 octaves, that is 3 times our frequency is being doubled. Once from 1 to 2,
There is 3 octaves. 1, 2.
1, see what is 1 octave? The doubling of frequency, correct? So from 1 to 2, first octave, from 2 to 4, second octave, from 4 to 8, third octave.
Okay.
Yeah, okay. So here we have
Okay.
3 octaves.
Okay.
Okay, and if I have a slope of minus 6 dB per octave and I go 3 octaves, then what? Net drop
Sorry.
will be, yeah, minus 18 dB. So
Yeah. Yeah.
from 20 log K, if I drop 18 dB, I am saying I am reaching 0. That means 20 log K is equal to 18 dB.
Yeah. Minus 18, no? Or it. Okay. Okay. 18.
Yeah, 18, no?
It will slope. So.
Yeah,
Yeah.
this is some 10 value, and so slope is 5 per unit, 1, 2, right? So same thing, minus, yeah. So from this we can get the value of K. Is this clear to everyone? Does anyone have any doubts?
No, sir.
Okay. Yeah, so
So
next,
the starting, if in the same graph, if the starting value is given, then I can equate directly 20 log K to that value. Isn't it easy?
yeah, if the starting value at frequency 1 is given, then you can directly equate it to 20 log K. But if at some other frequency is given, you have to plug in those frequencies and
Minus. Okay.
yeah, okay. Then, yeah. So the next question is, what are the values of A and B? Okay, I'll copy this. Okay, we can just move back here. So as one of you pointed out earlier, we have a pole at origin, pole at origin, 1 0 at 1, another 0 at 1, sorry, this is at 2, this is at 4, one pole at 8, another pole at 24, and finally another pole at 36. So when you look at the transfer function, this corresponds to the 0 at 2, and this corresponds to the pole at 8, this corresponds to the pole at 36. So two remaining things are there. This one, the pole is at 1 by A, and this one, the pole is at 1 by B, correct? So
1 by 4 and 1 by 24.
yeah, 2 is here, 8 and 36 are there, so these two are the remaining ones, 0 at 4 and pole at 24. So from that, 1 by A is equal to 4 and 1 by B is equal to 24. So A is equal to 0.25 and B is equal to some 0.0416. Okay, so this one was simple, I guess. Is the border plot thing clear? Anyone has any doubts in this K calculation?
No.
Okay, so we move forward. Yeah, so now we have the transfer function V naught, we have this system. On the left hand side, we have some circuit, V1 is being applied, RC circuit is there is V2, we have to find out and on the right hand side, this is a voltage dependent source and some other circuit R and C. We want to find out the transfer function of V naught by V1. So how do we go about this?
So there is no connection between those two circuits.
Okay. So first, let us write the KVL for this circuit and find the transfer function here. Just give me the transfer function between V2 and V1.
R1 plus 1 by CS.
R1 plus 1 by C1S is what?
V1 by V2, sir.
V1 by V2 is this. V1
Into
by,
I.
I'm sorry, V1 by, just a minute. I want this thing, V2 by V1. So you can very simply write this, like you can find the I1, right? That will be V1 by R1 plus 1 by SC1, and V2 is 1 by SC1
Into
into,
I1.
yeah, I1, correct. So V2 is nothing but V1 1 by SC1 into by R1 plus 1 by SC1. So this is V1 by 1 plus R1 C1 S. Okay. So this is the first transfer function of the left hand side. Similarly, give me the transfer function for this equation, V0 by V2.
The previous, this is over because I had a network issue. I disconnected and joined back.
The border plot one?
That previous, that K calculated. After that,
Okay, so I'll just go over it quickly. So the next thing we want to find out is the value of A and B. Okay.
okay, okay,
So you can see that in the given border plot I am given every pole and zero value. Okay. There is a pole at origin, we saw that.
yeah, yeah,
Then we see that there is a 0 at 2, another 0 at 4, one pole at 8, one pole at 24, and another pole at 36. Correct?
correct, correct.
Yeah. So, and from the given transfer function, we can see that this is the 0 at 2, pole at 8, pole at 36. So, 1 0 and 1 pole is missing. So, from that we can find out that the 0 is 4 and the pole is 24. So, the calculation is just 1 by A equal to 4, 1 by B equal to 24.
Can be interchanged also, no?
It cannot be interchanged because A is in the 0 and B is in the pole.
Okay, okay.
If both
Zero.
were in pole or both were in 0, then it can be interchanged. But for this, it cannot be. Clear?
Yeah, sure, sure.
Yeah, sure. So then we move on to this question. So what we want to find out is the transfer function between V0 and V1. So for the left hand side, you can see that this is the current and V2 can be found out as current into 1 by SC1 into the impedance of the what do we say, element, impedance element. Then V2 can be found, V2 by V1 can be found out as this transfer function. Similarly, give me a transfer function between V0 and V2. So again we can see that I2 will be KV2 by R2 plus 1 by CS2, sorry, SC2, and V0 is K R2 V2 by R2 plus 1 by SC2. So then V0 by V2 becomes, yeah, K R2 C2 S by 1 plus R2 C2 S. Then V0 by V1 we want to find out. So V2 by V1 we have V0 by V2, so this is basically V0 by V2 into V2 by V1, that is equal to K R2 C2 S by 1 plus R1 C1 S into 1 plus R2 C2 S. Okay, so this is the transfer function. I hope everyone is clear in this one. This is basic finding of the transfer function thing. Then we move on. We want to find out the Bode plot of that transfer function. Okay, of this transfer function. Now what is this? We have,
Can you go to the previous slide once again?
okay,
Can you just explain this V2 portion once again?
yeah, sure. So V2, this right hand side loop you are asking, right? Okay, so see, this is the source, right? So source by impedance, that will give me the current. Okay, so I2 is source by the impedance, that is R2 plus 1 by S C2. Now if we, then what do we want to find out? We want to find out V0. So this is I2, V0 is what? I2 R2, correct? So V0 is this one, I2 into R2, just R2 is multiplied into this term. So now from this we can obtain V0 by V2, which is this one. Then this calculation is straightforward. Is that clear?
Yes.
Okay. Okay. So now we have this transfer function. Someone give me the Bode plot of this. Like, you need not find out the exact values, just a rough sketch. First, let us write down where the zeros and poles are. 0 at origin. Then pole at 1 by R1 C1 and another pole at 1 by R2 C2. So now see that R2 C2 greater than R1 C1. So 1 by R1 C1 will be greater than 1 by R2 C2. So 1 by R1 C1 will be greater than 1 by R2 C2. So we'll have things like this. Then at 0 we'll have some 20 log K R2 C2 as the magnitude. I don't know what the values of K R2 and C2 are, so that doesn't matter. Let's say it starts from somewhere here. So we'll have a 0 here till here. When we encounter our first pole, so this will be plus 20 dB per decade. Then it will drop down due to the addition of pole to 0 dB per decade. Then further, when we encounter the final pole, we'll have minus 20 dB per decade. Is this clear?
How you are deciding that it will increase, it will continue, it will decrease minus 20 dB per pole?
Okay. So the way we plot Bode plots, how is it? Like, this is basically the Gj omega, right? This plot.
Yeah.
So when we write, say I have a transfer function, say let's take a transfer function h of s equal to s by 1 plus s into 1 plus s by 2. Okay, so I want to plot hj omega, which is j omega by 1 plus j omega into 1 plus j omega by 2. So we want to plot the 20 log of this h j omega magnitude, so that we get the decibel value. So this one you can see that it is 20 log omega minus some 20 log root 1 plus omega square and so on. Okay, we can find that out. But basically, asymptotically when we draw, whenever a 0 comes, we'll have plus 20 dB per decade slope. After that, when a pole is encountered, you will, to the existing slope you will add minus 20. If two poles are encountered, you will add minus 40 and so on. Okay, if you go through the Bode plot lectures, this one will become clear. So, since there is a 0 at origin, at the beginning we'll have plus 20 dB per decade. Then when we encounter the first pole, plus 20 minus 20 will get 0 dB per decade. And after encountering the second pole, the slope will become minus 20 dB per decade.
Okay.
Okay. Okay. So now consider a unity feedback system with the open loop transfer function k by s into s plus 6 whole square. What is the value of k which guarantees the gain margin of the system as 6 dB? Okay, so first someone tell me what is the gain margin of the system? Just give me the definition. What is the gain margin of the system? Okay, so the gain margin of a system. Someone is speaking something?
So is it 1 by the magnitude?
Yeah, it is 1 by the magnitude at what?
Magnitude at phase crossover frequency.
Yeah, okay, so I'll just explain
20 log.
Yeah, just a minute. So suppose I have a magnitude plot and this is the phase plot, okay? Something like this and say something like this. Sorry. Say this is 180 degree and this is 0 dB. Okay. So the gain margin is, take the frequency at which phase crosses 180 degree, this frequency, phase crossover frequency, find the magnitude in the Bode plot, add the phase crossover frequency, whatever is the magnitude from 0 dB, that is the gain margin. So basically 20 log 1 by m PC. That is, we are taking 1 by MPC because this value is actually negative, but we are taking it as positive. It is just a convention that so since this is 0 dB, this must be some negative decibel value, right? So when I take 20 log MPC, this will be some negative quantity. So by convention, we define the gain margin as minus 20 log MPC. So that is 20 log 1 by MPC, where MPC is the magnitude of the transfer function at the phase crossover frequency. Okay, is that clear to everyone?
Yes.
Okay. So now tell me, how do we find out the phase crossover frequency of this transfer function?
We replace s by j omega and
We replace S by j
We
omega.
equate the imaginary part to 0.
Okay, that is correct. Okay, so
We rationalize
yeah,
and separate the real and imaginary.
yeah, okay. Or another thing that we can do is we can directly find out the phase of this transfer function, angle of g j omega.
Tan inverse.
Yeah, so that is for this one, what is it? Minus 90 degree and minus tan inverse 2 tan inverse omega by 6. Okay, is that correct? Is this understood by everyone?
Yes.
Yeah. So this one we need to be minus 180 degree. Correct. So then this
Minus
will
90 and minus 90 degree, how it came? I'm not clear.
okay. So when I have a say only k by j omega, then what is this? This is minus jk by omega, right? So what is the phase of this? Minus 90 degree, correct?
Yeah, yeah.
Okay. So then, so when we have multiple poles or multiple zeros, we just for poles we subtract their. So basically, if I have something j omega plus a, j omega into j omega plus b, then the angle of this entire thing is tan inverse omega by a, that is the angle of the zero, that will be in positive, minus angle of first pole minus angle of second pole. So first pole is only j omega, so 90 degree minus tan inverse omega by b. Is that understood?
Yeah.
Yes.
Yeah, okay. So then, so okay, we have this term as the angle of the given transfer function. Okay, so we want to find out the phase crossover frequency, that is the frequency at which this angle becomes minus 180 degree. Correct? So we can simply equate it to minus 180 degree, and this will be the phase crossover frequency. So that means so someone help me solve this.
6 radians per second.
6 radians per second. Yeah, that's correct. So this is basically 2 tan inverse omega pc by 6 equal to 90 degree. That means tan inverse omega pc by 6 equal to 45 degree. That means omega pc is 6. So this is 6 radians per second. So now what do you want to find out? We want to find out the value of k, which guarantees the gain margin of the system as 6 dB. Okay, so at this omega pc, now we substitute this back in. What will be the gain of the system? So first gj omega will be k by j6 into j6 plus 6 whole square. So what will be the gain at this value? Or let us just find out. So I'll write 20 log gj omega, right? So what will this be? 20 log k minus 20 log 6 minus the last term. Okay, so then when I substitute, so what did we tell? The gain margin was 20 log 1 by this, or basically the negative of this. Okay, so this is 20 log. Since we are adding logs, everything inside will be multiplied. Omega pc or 6 into this omega pc plus 6 whole square. by k is equal to 6. So when we solve k, this will be 216.5. Okay. So is that clear?
So can you repeat once again?
Okay. Yeah, so okay, some you help me find out this value. Say this is j omega plus 6 whole square, right? So now tell me what should the value of, okay, let us just write this in normalized form, k by, or just, okay, just tell me this value, 20 log mod of j omega, what should this be? So since this is minus 20 log mod k by omega into j omega plus 6 whole square, correct?
Yes, sir.
So this is what, minus 20 log, assuming k is positive and omega is also positive obviously. So this one is what, omega square plus 6 square, correct?
Yes, sir.
So this is minus 20 log, so that means this is 20 log omega into omega square plus 6 square by k. Now we want this to be 6 dB. Okay, this is the gain margin. We want the gain margin to be 6 dB. So from this, that is at omega, at phase crossover frequency, we can plug in the value of the phase crossover frequency as 6 radian per second that we found out. Then what we'll have is 6 into 6 square plus 6 square by k, 20 log of that is 6 dB. So from that we can solve for the value of k. Is that correct?
Sir, if the
If the
if the denominator, if the equation was k by j omega into j omega plus 6, then its magnitude will be k divided by omega into root over omega square plus 6 square, isn't it, sir?
root over omega square plus 6 square, yes, that is correct, but we have j omega plus 6 whole square, right? So root over omega square plus 6
okay.
square,
Now I
its whole
understand.
square, yeah.
Okay.
Yeah. So from this you can find the value of k from this equation. It is just solving for this. Then so basically this you are finding the value of the gain, which will guarantee a certain gain margin for the system. Okay. Yeah. So is this question clear to everyone?
Can you please explain the last portion?
Yeah. Okay. I'll just go over it again. Wait a minute. So we have j omega is given by k by j omega into j omega plus 6 whole square. So you are clear on this part that we want to find out the gain of the system at phase crossover frequency, right? That is, we want to find out this term. Okay. So from there, so I have this is j omega. So I want to find MPC. So M is what, the gain of the system, the magnitude. So let us just first find out j omega mod. Okay, this is what, k by omega by j omega plus 6 j omega plus 6 into j omega plus 6. Okay, so this is k by omega into omega square plus 6 square. Is it clear till now?
Yes, sir.
Yes.
Okay. So from here then I want to find 20 log 1 by this thing, add the phase crossover frequency. So 20 log 1 by mod g j omega pc. Okay. So this is 20 log omega pc into omega pc square plus 6 square by k. So this value I want to be 6 dB, the gain margin. So this is 6. So now you can solve for k, that is log plug in 6 here, 6 into 6 square plus 6 square, that is 6 into 72. What is this value? I do not have a calculator. Can someone help me with this? Four 38. Tell me if I'm wrong. So 20 log 438 by k is equal to 6. So this implies 438 by k is equal to 10 to the power 6 3 by, 10 to the power 0.3, and so k is 438 by 10 whole to the power 0.3. So this can someone find this value? Okay, as per my calculations earlier, this is 216.51. Okay, so is this clear now? What we did here was we were given a transfer function.
Yes.
Okay,
Now.
yeah,
Yeah.
so it is, yeah. So is everyone clear on this? Can we move forward? Yeah, okay.
Yes, sir.
So we'll move forward. Yeah, so this is the final question for today. Draw the Nyquist plot for the unity feedback system with open loop transfer function given by g of s is this. So first let us draw the open loop poles. Okay, so one pole at 0, one at -3, one at -5. Now for the Nyquist plot, what we do is we take a contour that covers the entire right half plane and map it via this mapping to see whether it encircles -1 or not. From that we have a relation between the open loop poles and the number of open loop poles and the number of closed loop poles. Yeah. So here we will be fine mapping this by g of s. So see that this curve, entire big curve, has 4 parts. One is here from 0 to infinity, this from infinity to infinity, the angle changing from 90 degree to -90 degree, and this minus infinity to 0, and this one a very small, just a 0 point, but a small detour around the, so that this pole is not included. Okay, so first write gj omega, this is k by j omega into j omega plus 3 into j omega plus 5. So now first let us plot the part where omega is equal to 0 to infinity. So in that part, first tell me what is the value at 0.
When omega is 0, magnitude is infinity.
Infinite.
Infinite. At what angle?
minus 90.
Minus 90 degree, correct. Yeah, because these two will be 0, so it will be 3 into 5, but this 0 will dominate the whole thing because it will make the thing infinity. So we'll basically have minus j infinity, which is infinity at minus 90 degree. Yeah. So next we can plot this part. We are coming from infinity at minus 90 degree, and then okay, next we have to find out gj infinity. What will this be?
Magnitude 0.
Magnitude will be 0, correct. At what angle?
0.
Why will it be 0?
270.
Yes, if you substitute infinity here, like let us substitute a very large number. Okay, so how we do this calculation is we take gjr and find limit r goes to infinity. Okay, so this is k by jr, so jr plus 3 into jr plus 5. This is k by jr whole cube, because these are very large terms, so these two will dominate 3 and 5, so we'll have jr cube. So this is minus j square is minus 1, yeah. Okay, so this is j k by r cube, limit r goes to infinity. So magnitude is 0, but the angle is plus 90 degree or minus 270 degree. 0 at plus 90 degree. So that means starting at omega equal to 0, I'll come from somewhere at infinity on the negative j omega axis and then go to 0 at an angle of 90 degree. Okay, so clearly there will be some real axis crossing. Is that correct? Because obviously we cannot come from the below and then go like this to the origin from minus 90 to plus 90. So that is why there has to be some crossing. So now if you okay, so we did the omega equal to 0 to infinity part. Now we will move on to some next portion of the curve. So we can, for omega equal to minus infinity to 0, it will be completely identical to 0 to infinity, just that it will be flipped about the real axis. So that will be given by something like this. Okay, and for this small circle, okay, first let's take this large circle. This large circle will be mapped to something here.
The
Okay,
second one is not clear.
which one? The minus
Sir,
infinity
second
to
one
0?
is not.
Okay, we'll do it completely. This minus infinity to 0, right?
0 to
Just the
infinity.
mirror image, no sir?
I'm sorry, could one of you speak?
No, it is just the mirror image of the previous one.
Yeah, from 0 to infinity. Okay, we can do it just once again. So like we did the analysis in this part, okay, so omega equal to minus infinity to 0. So first let us plug in omega equal to minus infinity, right? So that will be minus jr, r goes to infinity. So what we'll have here is limit r goes to infinity. Basically this thing, just that it will be minus r. So we'll have minus j k by r cube. So this is 0 at an angle minus 90 degree. And for omega equal to 0, it will be the same thing, because at 0 it will be the same. So that will give us infinity at an angle. Okay. So one thing to note here is that here we are starting from some 0 plus, because there is a small circle that circumvents the pole at origin. So this part starts from some 0 plus. Okay. So given that starting from 0 plus we'll have infinity at minus 90 degree, but at 0 minus we'll have infinity at plus 90 degree. Is that correct? Infinity at no, sorry, this one will also be, it will be the same, because at 0 it won't matter. If you plug in 0, then only this part will remain, that is k by j omega, and that is basically infinity at minus 90 degree. So first part is clear. We come from infinity at minus 90 degree somewhere here to 0 at plus 90 degree, 0 at plus 90 degree, this one. And for this minus infinity, what do we have? Where is minus infinity? Yeah. 0 at minus 90 degree, 0 at minus 90 degree from this direction to infinity. Okay, sorry. I think I messed up somewhere. Let's plug in the value gj omega small r, limit r goes to 0 plus is equal to k by jr into 3 into 5 is equal to
At an angle plus 270.
which one?
Minus infinity, sir.
Minus infinity will be 0 at an angle, plus 270 is minus 90 degree, correct?
Yes, sir.
Yeah. So see that when we have 0 plus, we are getting 0 at, if I have 0 plus, I'm getting infinity at minus 90 degree, and if I have 0 minus, then I will get infinity at plus 90 degree. So I was correct here. Yeah. So okay, just is everyone on board with this? Is everyone clear till now? Any doubts here? Okay, yeah. So when we were doing 0 plus to infinity, we put in g0, we got g0 plus, we got infinity at minus 90 degree. So somewhere from here will come at from infinity at minus 90 degree and end up at 0 with an angle plus 90 degree. Okay, then when I move from minus infinity, at minus infinity I have 0 minus 90 degree, so this portion, and at 0 minus I have infinity plus 90 degree, so it will go over there. Is it clear to everyone?
Can you repeat, sir? Last, I'm not getting that, how it is going up.
Till which part you got?
From this, whatever infinity angle 90, that is clear. How you are plotting that upward? Just
Okay. See, when we are at minus infinity, we should have 0 at minus 90 degree. That is clear?
is 0 infinity. What you are telling now, minus infinity to 0. That is clear.
Okay, this is clear.
That is clear.
Are you clear with this?
Yeah.
Okay, so at omega equal to minus infinity, g of j omega is 0 at minus 90 degree. Okay.
Yeah.
So what is 0 at minus 90 degree? So basically that means, sorry, I am at magnitude 0, but the direction is minus 90 degree.
Correct.
Okay, so I'll kind of leave 0 just touching the minus 90 degree curve, like this direction. At 0 that should be the tangent direction. But then at omega equal to 0 minus, it is infinity at plus 90 degree. So plus 90 degree is what? This axis. So
Yes.
as 0 minus, I go towards 0 minus, I will go to infinity in the plus axis. So at 0, so I leave this way and go somewhere above that way.
Okay.
Correct?
Okay.
Yeah. So basically you need not plot both these parts. If you plot 0 to infinity, the minus infinity to 0 will just be the symmetric version of it about the x-axis, about the real axis. So this is the Nyquist plot, and what next? Yeah, this bigger loop will be to some 0 point. We need not care about that. This small loop, we can estimate it okay. Okay. So now this small loop, okay, that small loop can be given by r e to the power j theta, where r tends to 0 and theta goes from minus 90 degree to 90 degree. Is this clear to everyone? Like what I am saying is, we map this big contour that encircles the entire right half plane via this function to this thing, right? So we are done with this part, and with this part, but this part is remaining. So for that we can, that can be this is kind of just a circular region, so that can be given by r e to the power j theta, where r is very small, we can take it limit tending to 0, and theta varies from minus 90 degree, the negative j axis, to plus 90 degree, the positive j axis. Then when we substitute this r e to the power j theta, we have k by r e to the power j theta, r e to the power j theta plus 3 r e to the power j theta plus 5. Yeah. So now we take limit r goes to 0. So that will give me, so see that these two terms will be dominated by 3 and 5. So all that will be remaining is this. So that will just give me infinity e to the power minus j theta. So that is infinity at an angle minus theta. So original theta move from minus 90 degree to plus 90 degree. So this one will move from, since it is minus theta, this will move from 90 degree to minus 90 degree. So basically at infinity we'll have an infinitely large circle that will move from plus 90 degree to minus 90 degree, like this. Is it clear to everyone?
Yes.
Okay. So with that we are done with today's problems. Do you have any further doubts in,
Sir,
like,
you are saying, one second, sir. You are saying, I understood 92 minus 90, I understood. But what you are plotting, that not getting.
see, when we plotted this part minus infinity to 0, okay, that is this one, correct?
Yeah, that is clear.
Then
So that clear.
then we will be plotting this part, whatever it is mapped here, correct? See, we are mapping this contour to via this function, right? So I did this one.
Map who was
Yeah, what? Could you repeat? I did not get it. What were you asking?
How you decided that we have to map this total
Okay, so
circle down to that,
that is basically
and then we decide that that has to be.
no, like did you go through the lectures of Nyquist plot?
Not fully, sir.
Then if you go through it, this part will be clear. It will be explained. Like we have to map this entire contour to the GFS. That if I explain that entire thing, that will take a lot of time. But
Okay.
if you go through the lectures, it will be clear.
Okay. Okay.
Yeah.
Then the small circle.
The small circle, yeah. So, okay. So now just assume that I have to map this contour. Okay. So this part is this thing, right?
Yeah. Yeah.
Next, from here somewhere, this part will come, continuity kind of, right? So small contour, we saw that it gave
Continuity will come.
infinity at minus theta. So from infinity at 90 degree to infinity at minus 90 degree. And we saw that when we mapped this part, it went from 0 to infinity at 90 degree.
Yes. Yes.
So
Yes.
then from there infinity at 90 degree to infinity at minus 90 degree, this plot will come. Then from here, from here the 0 part will start, 0 to plus infinity. So this way the entire plot is made. Is it clear?
Yes, sir.
Okay. So with that we can stop for today's session, and yeah, practice as many problems as possible. Only after that this Nyquist plot and all will feel comfortable. But the concept is same only. We want to map the entire right half plane and see whether there are any encirclements of the -1 thing or not. That will give us the number of closed loop poles in the right half plane of the number of closed loop poles. Yeah. So with that we'll
Here
continue.
is this
Yeah.
any encircle -1 plus Z0. How to understand that one?
Sorry, I didn't get you. -1 plus.
In this Nyquist plot, in the problem given in problem number 7, in this Nyquist plot, how can we understand that it encircles -1 plus Z0 or not?
Okay. For that we can calculate the this value. Okay. So how do we do that? We can, yeah. So let us just consider the part where we took omega equal to 0 to infinity. Okay. So that is this part, correct? So now I want to find out the point where I cross the real axis. So I can find
So
out.
for the back calculation, we will consider that angle will be -180 degree in that way.
Yeah, we can find out Gj omega and just put in the imaginary part equal to 0. So I'll write it directly. The Gj omega that you have, if you simplify, rationalize it, you will get this term minus j 15 omega minus omega cube by 64 omega to the power 4 plus omega square 15 minus omega square. Okay, so when you rationalize this Gj omega, you will get this term. So I want to put the imaginary part as 0. So omega is equal to root 15. So at this point, the frequency will be omega equal to root 15. Okay, so add omega equal to root 15. Then what next? Yeah, I can find out Gj omega directly. So that will be minus of 1 by some 8.15, I guess. Okay, so this one this is clearly less than -1. Okay, so there are no encirclements, but that is for k equal to 1. So whenever you are given a Nyquist plot, put k equal to 1, find all the crossing and everything. Then for any k, this will be just translated by k, that scaled up by k, so minus k by 8.15. So if k equal to 8.15, then I will be, then the Nyquist plot will be something like this, minus 1. Okay, so then if it further went forward, then you can see that there are encirclements around the minus 1 point. So then you will put in that value n equal to z equal to p minus n. Then you will plug everything in, how many encirclements are there and so on. So we saw that there are no open loop poles in the right half plane, so this is 0. N is the number of counterclockwise encirclements. But here, suppose you took a k value greater than 8.15, then minus 1 will be somewhere here. So here you have 2 encirclements. So that will give me 2, this will be minus 2 because it is clockwise encirclement. So this will give me 2 closed loop poles in the right half plane. So from that we can see that for k greater than 8.15, our system is unstable. So for the system to be stable, we want k less than 8.15. Okay? Is it clear?
Okay.
Yeah. So this way you can do the analysis. Yeah. So any other doubts?
If the Nyquist plot cuts the minus 1 plus J0, then what will be the stability?
It will be marginally stable.
Marginally. Okay.
Yeah. So when you have to find out marginal stability, you'll put k equal to 8.15. Yeah. Yeah. So is that clear for everyone?
Yes, sir.
Okay. So with that, we'll conclude for today. Thank you for attending the thank you for attending the session.